Hello, this lesson will be dealing with the possibility of reinforcing high-strength concrete using fibers. First of all, it has to be defined what is a high-strength concrete. The definition depends on what is considered a conventional concrete and a high-strength concrete. In Spain, and according to the Structural Concrete Code EH08, a high-strength concrete is considered of such type if its characteristic strength is greater than 50 megapascals. This type of concrete appears thanks to the use of two components, silica fume and superplasticizers. High buildings, all extraction platforms and bridges have taken advantage of the outstanding mechanical properties that this concrete has. The components of high-strength concrete are water, cement, fine and coarse aggregates, and other products would range from chemical additives to certain cement additions. Nevertheless, there are some considerations that have to be kept in mind. In high-strength concrete, the water-cement ratio should be low because there is a direct relation between the compressive strength and such ratio. This phenomenon can be clearly observed in the figure that appear in the slide. Independently of the strength of the cement that appear in the pink, blue or green lines, the compressive strength of the concrete increases as the water-cement ratio decreases, having greater improvements for water-binding ratios below 0.4. To achieve a proper workability having such low ratios, the use of superplasticizer is highly encouraged. It cannot be overlooked that for the same water-cement ratio, the higher strength of cement provides the highest strength of concrete, as can be seen comparing the blue line with the pink or the green ones. Regarding the aggregates, they should have a remarkable compressive strength. Also, some cement additions, especially silica fume, can be used. Focusing on the characteristics of cement, it is recommended to use cements with high strength of 42.5 or 52.5 megapascals. Among the types considered in the Spanish code, a cement type 1 is the most adequate for this type of concrete. The amount of cement employed per cubic meter is over 400 kilograms. And finally, as could be observed in the last slide, there is no direct relation between the cement strength and the compressive strength of the concrete. Regarding the aggregates used, it has to be said that the coarse aggregates should have at least the desired compressive strength of the concrete formulated. Another factor that should not be overlooked is that the aggregate shape ought to be as close as possible to cubes. Of course, and similar to what is required in conventional concretes, the aggregates should be clean of dust, organic substances, or other type of dirtiness. It is recommended that they should have a maximum size smaller than 15 millimeters, having usually a maximum size between 10 and 12.5 millimeters. Some of the most employed aggregates are granite, basalt, quartzite, and certain types of limestone. In the case of the fine aggregates, it is important to use rounded sand with good mechanical properties. The ratio between the coarse and the fine aggregates should be close to 1.5. As was previously stated, apart from the classic components of concrete, some others can be used. Among them, one that is commonly employed is silica fume. Silica fume is a byproduct of the metallurgical industry. When added to concrete, such byproduct promotes puzzolanic reactions, improving the mechanical behavior of concrete and reducing the water exudation. However, there are some side effects that should be taken into account. The water dosage should be increased in order to maintain the same concrete workability. And the silica fume also increases the plastic shrinkage. Superplasticizer is commonly employed in high-strength concrete. As previously commented, it has to be used to obtain good workability using water-cement ratios lower than 0.4. When it is used, it is common to obtain fluid or liquid viscosities. Nevertheless, concrete setting is retarded, and if some other chemical product is used, a compatibility test between those products should be undertaken. Some other aspects that have to be considered are those related with the mixing process and the concrete properties. The duration of the mixing has to be longer than in a conventional concrete, and also the duration of the effect of the superplasticizer has to be considered. In what concerns the concrete properties, it has to be reminded that the evolution of strength is faster than in a conventional concrete, and if silica fume is exploited, there might be increments of such compressive strength beyond 28 days of age. Summarizing, the pros of the high-strength concrete are its fast evolution of strength, which depends on the type of cement, its gain of strength beyond 28 days of age, its mainly linear relation between stresses and strains, and its increased durability. On the contrary, due to the high contents of binder, the plastic shrinkage is greater than in a conventional concrete. In addition, it has a worse fire resistance and it has a fragile behavior when damaging. To improve and overcome some of these problems, the use of fibers is highly recommended. To reduce the plastic shrinkage and to improve the fire resistance of concrete, polypropylene fibers are commonly used. In the case of the failure modes, steel fibers are a suitable option. However, a possibility that should be considered is the use of polyolefin fiber macrofibers to solve all the issues that were previously commented. Thank you for your attention.